All right, so get this. Scientists are creating light hurricanes.
Light hurricane.
Yeah, you heard that right.
Okay.
Light hurricanes that can make your internet 16 times faster.
Wow.
16 times. We're diving into this article from scitechdaily.com about research happening at Aalto University in Finland.
Yeah, it's pretty remarkable research. Right now, data in fiber optic cables travels as pulses of laser light.
Right.
But these researchers have found a way to pack even more data into each pulse using something called a light vortex.
Okay, hold on. A light hurricane. A vortex, what are we talking about here?
So imagine a tiny spinning hurricane of light.
Yeah.
And there's a calm, dark center. And around that light is swirling in a ring, like a spinning ring of light.
So kind of like the eye of a hurricane, but with light.
Yeah, just on a microscopic scale.
Okay, got it. But how do you even create a light hurricane in the first place?
Well, that's where things get really interesting. They're using these things called quasicrystals to manipulate tiny metallic particles called nanoparticles.
Nanoparticles.
Yeah, think of it like arranging furniture.
Okay.
The way you arrange these nanoparticles determines the kind of vortex that you get.
So quasicrystals are like the blueprint for the light hurricane.
Exactly. Previous research used simpler shapes like squares or hexagons to arrange the nanoparticles, but quasicrystals allow for much more complex patterns.
I see.
And what's cool is that theoretically you can create any kind of vortex you want with the right quasicrystal pattern.
Wow. So it's not just about speed, it's about having more control over the light itself.
Yeah.
But how do these nanoparticles actually shape the light?
It all comes down to electric fields.
Okay.
Think of it like a crowded dance floor.
Okay, a dance.
There are hot spots where everyone's moving, and then there are those empty corners. Those are the dead spots of the dance floor, or in this case, the electric field.
Okay, I can picture that. So they're putting these nanoparticles in the dead spots of the electric field.
Precisely by strategically placing the nanoparticles in those dead spots. They're essentially forcing the light to move in a specific way, creating that vortex pattern.
So they're shutting down all the other dance moves to create this perfect light hurricane.
Exactly. They're choreographing the light.
That's brilliant. Yeah. Okay, so we've heard the hype about 8 to 16 times faster internet. But what does that actually mean for us? Like, what kind of difference would that make in our everyday lives?
Well, imagine a world where downloading a movie takes seconds, not minutes.
Oh, wow.
Video calls are crystal clear with no lag or buffering.
That would be amazing.
And things like telemedicine could become even more effective with doctors being able to perform remote surgeries with real-time precision.
Wow, that's a game changer. It's not just about entertainment. It's about connecting people in ways we can barely imagine right now.
Exactly. And it's not just about speed. This technology could also make data transmission more secure.
More secure? How so?
Well, the unique properties of these light vortices make them very difficult to intercept, like trying to eavesdrop on a whispered conversation in a hurricane.
I see.
Plus, because they can carry more information, we could potentially use less energy to transmit data, which is great for the environment.
So we're talking faster, safer, and greener internet? This is starting to sound like a win-win-win situation.
It certainly has that potential, but it's important to remember that this is still early-stage research.
Right.
There are a lot of engineering challenges to overcome before we see light hurricanes powering our internet.
Well, let's dive into those challenges and explore what it would take to bring this technology to life. What are the next steps for these researchers at Aalto University?
Well, one of the biggest hurdles is figuring out how to make these quasicrystal structures on a larger scale.
Right, because right now
they've only been able to create them in a lab setting.
Yeah.
Which is great for a proof of concept.
Of course.
But not so practical for rewiring the entire internet.
So it's like they've baked this amazing one-of-a-kind cake.
Yeah.
But now they need to figure out how to mass produce it for everyone to enjoy.
That's a great analogy, and it's not just about baking more cakes. It's about baking them with the same level of precision and consistency. We're talking about manipulating materials at the nanoscale, which requires incredibly sophisticated techniques.
I can only imagine. But let's say they crack the code on mass production.
Okay.
What else stands in the way of making light hurricane internet a reality?
Well, then comes the challenge of integrating these quasicrystals into existing fiber optic networks.
Oh, right.
It's not a simple plug-and-play situation.
So it's not like we'll be able to just upgrade our routers and suddenly have light hurricane internet.
Probably not. It's more like rewiring the entire planet.
Oh, wow.
Which is a massive undertaking, both logistically and financially.
Yeah, for sure.
Yeah.
Okay, so let's assume for a moment that we overcome all of these challenges. What are some of the other possibilities beyond faster internet? You mentioned security and energy efficiency, but what else could this technology unlock?
Well, the potential applications go far beyond just communication.
Okay, like what?
For example, imagine using light hurricanes for medical imaging.
Medical imaging.
Yeah, we could create incredibly detailed 3D images of the human body,
Wow.
allowing doctors to diagnose and treat diseases with unprecedented accuracy.
That's fascinating. It's like having a microscopic flashlight that can illuminate the inner workings of our cells.
Exactly, and think about sensing applications. We could use these light vortices to detect minute changes in the environment, from pollution levels to the presence of hazardous materials.
Oh, so we could have incredibly sensitive sensors that could alert us to environmental threats in real time.
Yeah.
That could be a game changer for everything from public safety to climate monitoring.
Absolutely. And then there's the realm of quantum computing, which is where things get really mind-bending.
Quantum computing, that's a topic I always hear about but never fully grasp. How would these light hurricanes fit into that world?
Well, quantum computing relies on the principles of quantum mechanics,
Right.
which govern the behavior of particles at the atomic and subatomic level.
Okay.
And light, believe it or not, can behave both as a wave and a particle. It has this weird duality.
So we could potentially use these light vortices to manipulate those quantum properties of light.
Exactly. And that's where it gets really exciting. Quantum computing has the potential to revolutionize fields like medicine materials, science, and artificial intelligence. And using light hurricanes to control quantum information could be a key piece of that puzzle.
It's like we're opening a door to a whole new universe of possibilities, all thanks to these tiny twisters of light. But with all this talk of futuristic technology, it's easy to get caught up in the excitement and overlook the potential downsides. Are there any risks or ethical considerations we need to be aware of?
Of course, as with any powerful technology, there's always the potential for misuse.
What kind of misuse are we talking about?
Well, for one thing, the increased speed and capacity of data transmission could exacerbate existing problems like information overload and the spread of misinformation.
Oh, right.
Imagine if fake news could travel 16 times faster.
Yeah.
It could have a devastating impact on society.
That's a sobering thought. It's like we're giving ourselves a more powerful engine, but we haven't necessarily upgraded the brakes or the steering wheel.
Exactly. We need to be thoughtful about how we develop and deploy this technology, ensuring that it benefits society as a whole, not just a select few. We need to consider the ethical implications and develop safeguards to prevent misuse.
It sounds like we're on the verge of a technological revolution, but with that comes a huge responsibility to wield this power wisely.
Absolutely. Technology is a tool, and like any tool, it can be used for good or for evil. It's up to us to decide which path we take.
Well said. This has been an incredible journey so far, from the microscopic world of light hurricanes to the vast potential of quantum computing. But I'm curious, what else are these researchers at Aalto University working on? Are there any other groundbreaking projects in the pipeline?
They're doing some fascinating work with superconductivity.
Superconductivity.
Yeah, which, to put it simply, is the ability of certain materials to conduct electricity with zero resistance.
Okay, zero resistance. That sounds like something straight out of a physics textbook. What does that mean in practical terms?
Well, imagine a world where we can transmit electricity without any loss of energy.
Wow.
Power grids would become incredibly efficient. Electric vehicles could travel much farther on a single charge.
Right.
And our reliance on fossil fuels would plummet.
Wow, that sounds like a revolution in energy. It's amazing to think that something like superconductivity, which sounds so abstract, could have such a tangible impact on our everyday lives.
Yeah, it really highlights the interconnectedness of scientific disciplines. Advances in one area, like materials. Science can have ripple effects across countless other fields, from energy to transportation to medicine.
And speaking of interconnectedness, I read that Aalto is also doing research on organic LEDs, or OLEDs,
Right.
which are already being used in some high-end TVs and smartphones.
That's right. OLEDs offer several advantages over traditional LCD displays.
Yeah.
They're thinner, more energy efficient, and produce incredibly vibrant colors and deeper blacks. Plus, they can be made flexible, opening up a whole new world of design possibilities.
Flexible screens. That sounds like something out of a sci-fi movie. Imagine being able to roll up your TV like a poster, or have a smartphone that curves around your wrist.
Yeah, the possibilities are really quite remarkable. And what's fascinating is that OLED technology is still evolving rapidly.
Really?
Researchers are constantly pushing the boundaries, developing new materials and manufacturing techniques to create even more efficient and versatile displays.
It's like we're witnessing the birth of a new technological era, where light is not just something we see, but a fundamental building block for everything from communication to energy to entertainment.
I think that's a brilliant observation. We're only just beginning to tap into the potential of light-based technologies, and who knows what other wonders will unlock in the years to come.
Well, on that note of wonder and possibility, I think it's time to wrap up this deep dive into the world of light hurricanes and beyond. Any final thoughts you'd like to leave our listeners with?
If there's one thing I hope our listeners take away from this deep dive, it's that science is not just a collection of facts and figures. It's a journey of discovery, a process of asking questions, challenging assumptions, and constantly pushing the boundaries of what we know and what's possible. And the most exciting discoveries often come from unexpected places, like the swirling eye of a tiny light hurricane.
Beautifully said. It's a reminder that curiosity is the fuel that drives innovation. So to our listeners out there, keep that spark of curiosity alive. Never stop asking questions, never stop exploring, and never stop wondering about the world around you. You never know what amazing discoveries await you just around the corner.
And perhaps one day you'll be the one making headlines with a groundbreaking discovery that changes the world.
Until then, happy diving.